Good evening. Now we are going to solve questions that is on particular integral, and here we are with only sine and cos function, not trigonometric. We are with sine and cos function. And for sine and cos function, how we can solve it by direct method, that is simple method that we will see. Now we have, this will be clearly, you have to keep in mind this is only for cos and sine. So now we have f of d that is equal to q. From this already we have seen y is equal to q upon f of d. Now particular integral, if we have this q that is equal to sine x, then we have sine or cos x, sine x oblique cos x divided by f of d. Now for this, we have particular integral y is equal to sine x upon f of d square upon d. That is d square comma d. And d square we have to put minus a square. What is a? A we have again coefficient of x. Coefficient of x. So here we have only sine x. So my value of a is 1. If I have sine 2x, then my value of a that is equal to 2. And then minus, so d square we have to replace by minus a square, and d will be as it is. In case of exponential function, we are going to replace d by a. But in case of sine cos function, we are going to replace d square by minus a square. D we cannot replace by a. So that we have to keep in mind. Means suppose we are going to consider this problem and we have d square plus d plus 1. Then what we have to go? We have a equal to 1. So a equal to 1. So we have a square also 1. And then we have minus a square equal to minus 1. So it becomes minus 1 plus d plus 1. And then we will get only that is equal to d. So your function becomes equal to sine x upon d. Now we have to put a d square equal to minus 1. So we have to rationalize, multiply it by d, divide it by d. And then we are going to get d upon d square sine x. And now put a d square that is equal to minus a square. So minus 1. And then we have minus d sine x. D is derivative. And derivative of sine x, we have minus cos x. Now those are from a diploma stream. So they have to keep in mind derivative of sine x, d dx of sine x, we have, cos x, d dx of cos x, or we can say d dx of cos x. So we have minus sine x. Now d dx of sine ax means sine 2x, sine 3x. You have a into cos ax. Now a value you may have 2, a value you may have 3, any value you have a. So that will be outside. And d dx of cos ax, you have minus a sine ax. So that you have to keep in mind. If we have sine 2x, then derivative we have 2 cos 2x. So whatever value of a, we have to take it outside. Here value is 1. So we have that is 1 cos x. And therefore 1 we are not going to write. So we have written it as minus cos x. So now we will go with one problem. So we have this as d square So we have d square minus 4d plus 3, and that is equal to, I am considering both functions sine and cos in one problem so that you can understand it. So 2 cos x plus sine x. And we are interested solution of this differential equation. So now first we have to go for complementary function. And for complementary function, we have to write auxiliary equation. So we have auxiliary equation m square minus 4m plus 3 equal to 0. Now I will directly write m minus 1, m minus 3, and that is equal to 0. Therefore, m1 equal to 1 and we have m2 equal to 3. So what is our complementary function? So complementary function we have. So we have complementary function C1 e raised to x plus C2 e raised to 3x. So this is our complementary function for this problem. Now we have to go for particular integral. Now for particular integral, we know particular integral. Now in this we have y is equal to q upon f of d, and we have d square equal to minus a square in case of this cos and sine function. So we will have particular integral y that is equal to 1 upon d square minus 4d plus 3, and then we have in this 2 cos x plus sin x. Now we will make it separate. So we have 1 upon d square minus 4d plus 3 into 2 cos x plus 1 upon d square minus 4d plus 3 into sin x. And now we will make it separate. We know we have to put d square equal to minus a square. Now in both we have value of a that is equal to 1. So in this also we have d square equal to minus 1. And in this case also d square equal to minus 1. That is d square equal to minus a square. And in both cases we have this value that is equal to minus 1. So now if we will put this value, so we have 1 upon, we have minus 1 minus 4d plus 3 into 2 cos x plus 1 upon minus 1 minus 4d plus 3 into sin x. And now if we will put this, then we have 1 upon, this is minus 1, this is 3. So we have 2. So we have 2 minus 4d. So 2 minus 4d, and that is into 2 cos x plus 1 upon, again we have same, that is 2 minus 4d into sin x. Now we can take, that is value 2 outside from this, and then we will get it equal to 1 by 2 into 1 upon 1 minus 2d into 2 cos x plus 1 upon 2 into 1 upon 1 minus 2d into sin x. And now we have to put d square equal to minus a square. So we have to rationalize it, and we have to multiply it by equal to. So this 2 we can cancel it, and we have cos x into 1 plus 2d divided by 1 minus 2d into 1 plus 2d. And the same we have for sin x also. Plus we have 1 plus 2d. You better always write before sin or cos x divided by 1 minus 2d, 1 plus 2d. And we have 1 minus 2d, 1 minus plus 2d, 1 minus 4d square. So we can write it as yp, you can write particular integral, that is equal to 1 plus 2d into cos x. This is d divided by 1 minus 4d square plus 1 plus 2d into sin x upon 2 in bracket 1 minus 4d square. And we know we have d square equal to minus a square, and here in both we have value as 1, so we have d square as minus 1, and therefore we will get yp, that is equal to 1 plus 2d into cos x divided by 1 minus 4 into minus 1 plus 1 plus 2d divided by 2 in bracket 1 minus 4 into minus 1 into sin x. And 1 minus minus 1, so 1 plus 4. So we will have yp is equal to 1 plus 2d upon 5 into cos x plus 1 plus 2d. Now we have this 5 and this 2 upon 10 sin x. And now we have to separate it. So we have cos x upon 5. We are multiplying it first with 1 plus we have second 2 by 5d cos x plus sin x upon 10 plus 2d upon 10 into sin x. And now we have to solve this. So we will get yp cos x upon 5 plus 2 by 5. Then we have this as derivative of cos x. I already mentioned it is minus sin x plus sin x upon 10 plus 2 by 10 becomes 1 by 5, and derivative of sin x we have cos x. So we will take cos x term closer. So we have cos x upon 5. This is first term. This term also we have cos x upon 5. So plus cos x upon 5. Then we have minus 2 by 5 sin x plus sin x upon 10. And then if we solve this, we have first two term directly 2 cos x upon 5. And in this we have 5 2s are, so into 2. So 2 2s are 4. And this 1. So we have minus. So this is 2 by 5. So this becomes sin x by 10. So just check the answer once. So we have 1 by 10. So sin x, and this is 2 cos x actually. So we have 2 by 5 over here. So 1 plus, so 2d we have over here. So this becomes 1 by 5. So 1 by 5 cos x. So 2 by 5, just see the calculation. So I got it as minus 3 sine x upon 10. Just check the calculations. So we have that is 1 by 5 sine x. I got it as 2 by 5. So 1 plus 2d and 1 by 5 cos x. So minus 3 sine x 10. So just check this coefficient and then we have solution, that is solution we have complementary function plus particular integral. And then we will get this value that is equal to complementary function we have c1 e raised to x c1 e raised to x plus c1 e raised to 3x plus 2 cos x upon 5 minus 3 sine x upon 10. So we have this. Just go any correction, just tell me, we can make it. So we have here 1 by 5 cos x. Then we have 1 plus 2d. So we have 2 by 5. That is sine x. And likewise, we will get these all values. And from this, we will get this answer. Just go through it. So this is for your sine and cos function. So now we will stop here only. So thank you. So for sine and cos, both we have to use same. Therefore, I have taken this in 1. And then next we will go with combination, that is e to the power, and then e to the power ax and sine cos x. Now we will stop here.